Welcome to our session for today. We are ByTed and we'll tell you a little bit more about us. But just before we start today, we can play a little animation so you can see just a little bit about what we're about. So we're from a company called ByTed. ByTed is based in New Zealand, and we design and create technology teaching resources for schools and educators and everybody else who's interested in computer science, essentially. The QR code that you can see on here will take you directly to our website, but if you want a direct link, we've got byted.com. It's very easy to remember, so you can hook into it at any time that you want to. So we'll just start with a karakia just to start the session today. Please feel free to say this along with us if you wish to. Unuhia te po whiri marama, tō te ao whatu tangata, tatai ki runga, tatai ki raro, tatai ahuro, humie, huie, taikie. And here at ByTed, we love the whakatauki pupue ti kākano kia po wai. Nurture the seed and it will blossom. Thomas.
Awesome. Kia ora, everyone. Tēnā koutou katoa. Ko te waro o te maunga, ko waro o te awa. Ko whangaruro te moana, ko Thomas Mel toko inoa. Nō reira, tēnā koutou katoa. My name is Thomas and I'm the lead XR developer here at ByEd. So I pretty much am in lead of anything that we work in terms of digital creations. So the Play Code Learn app side of things as we'll be going into today. But I also had a lot of the PLD that we offer for teachers and students learning how to create their own projects using AR and XR technology, which we'll talk a little bit more about later. I've got a background in software engineering, but primarily focused in app and game development. So I like to bring a lot of those design principles into all of our teaching resources as well. So we're really thinking about creating authentic projects and experiences, essentially.
Fantastic. Thank you, Thomas. Tēnā koutou ke tēnā koutou katoa. Ko ingarangi te whakapakawanga mai. Ko Lincolnshire te whenua tapu no skonfo au. Ko Aotearoa te kaina, te tahuna o e noho ana. Ko Sarah Washbrook toka ingoa. Nō reira, tēnā tātou katoa. So kia ora, everybody. My name is Sarah Washbrook. To give you a little bit of background about myself, I've been teaching STEM and technology for over 25 years, both in the UK and in New Zealand. Mostly in New Zealand, though, about 20 odd years here. And I've taught from year 1 to year 13, but predominantly in the primary level up to about year 10. That's been my main area of expertise. I started off in a high materials and DBC focus when I was looking at those kinds of tech areas, but really over the past 8 years or so, I've been looking at the integration and weaving of digital technologies, particularly with the curriculum refresh. I'm product development lead at ByTed, so that makes me responsible for coming up with and supporting the team with the creation of different teaching resources in computer science. I also have other things to do with technology as well. I'm deputy chair on TENS, which is Technology Education New Zealand, so that's a subject association that helps and supports educators in technology education. And I also train people at the University of Waikato to become secondary trained technology teachers. So quite a lot of things to do with tech ed, but obviously my main role here is with ByTed and the development of the resources that we come up with in regards to computational thinking and computer science. So today we're going to be going through basically a little bit about ByTed and a little bit about the focus of the types of digital technologies that we have been using over the past few years. Then we'll explore our Play Code Learn Dinosaur series. So we've now got a range of them, which is a little bit different to the webinar last year, if you joined us last year. And we'll have a look at those resources, and then we'll explain how we actually support any teachers that want to be involved with the work that we do. Thomas.
Cool. So just a little background into the rest of the team who aren't here today with us. We do have quite a few other members who have different disciplines that help us in the development of these products. So we have a lot of members who have helped us in terms of the digital side of creations, that's in terms of the asset design, creation, getting it in and testing it out. And we've also got lots of work with lots of teachers now, lots of schools as well, who help give us lots of feedback and work with us in developing lots of these products too. So before we jump into the main session, I just want to talk a little bit about the different realities that we're going to be kind of mentioning in this presentation. So we've got augmented reality, virtual reality, and mixed reality. And for those that don't know, the kind of catch-all term for all of these realities put together is called XR. So whenever you hear someone talking about XR devices or capability, it's kind of just a term that means it can kind of do any or some of the below, so augmented, virtual reality, and mixed reality. We've got quite a few different experiences that we'll be going over in just a moment that explore each of these different realities, but we find it really important to showcase how we can actually use these technologies and experience them as it's kind of becoming a bit more and more widespread adoption. You know, you see this sort of technology around the place a lot more now. Awesome. And we've got quite a few more of these dinosaurs. So for those of you, again, joining us from last year, these are the same ones that we've got in our kit. You'll see quite a few of them actually walking behind us at the moment. So we have made these little virtual backgrounds for us. They're not just random dinosaurs for no reason. This is part of our kit. And this is part of the design process that we've gone through. And we now actually have quite a few more that you'll probably be spotting throughout this presentation. And if you want to meet them in VR and not just have to look at these backgrounds that we've got behind us, we've actually got a virtual demo that you can go ahead and try yourself. So if you do want to try that out, you can scan the QR code on the screen there. It'll take you to just a page on our website that is hosting this free experience. And essentially it allows you to explore all of our assets, all of our dinosaurs in augmented and virtual reality. So what you're seeing right now is virtual reality. So you'll be able to hold up your device, turn your phone around and look around you in all 360 directions. You can also do it on a computer if you don't have a mobile phone on hand. So it has those accessibilities built in. If the QR code is not working for you, it's just underneath our demo section on our main webpage. So if you are lost, just look for any of those free demos and you'll be able to find it there as well.
Just for those people who are interested, Thomas, do you want to explain how you created our little virtual world here?
Yeah, sure. So this was a demo that we created using A-Frame. So the A-Frame is a free-to-use toolbox or set of tools, essentially, that allows you to create these virtual reality experiences using HTML programming. So some of you that will be doing these, you know, programming and computer science, HTML is probably come up quite a bit. It's, you know, creating how to create websites and design websites. You're actually able to create your own virtual reality experiences like this just using HTML-based tags, essentially. So it's a really fun way to explore this sort of thing, bringing in your assets and playing around with them without very little code involved.
Fantastic, thank you. And we'll move along to the next section. Like Thomas said, if you do want to explore our virtual reality world, you can find it through our main vited.com website. So that's a brief overview into the digital technologies part and how we as a company have developed a lot of our content and the main focus for our company when it comes to creating these technologies resources. What we discovered when we started to come up with our ideas was originally we actually created lots of teaching resources and content in the VR space, predominantly aimed at intermediate high school level. And this was awesome. The students could learn to create their own digital tools and create their own outcomes, really using our different tools that we introduced them to. However, what we were discovering was by they get to that age, there were still quite a lot of students that didn't have the basic concepts. They didn't understand the key ideas from computational thinking, and they couldn't actually name what they were doing. They couldn't explain clearly using the terminology that they needed to be able to understand for that higher level. So we came together as a team and decided that actually we wanted to go right back to the beginning and help and support teachers and students to actually develop these concepts and knowledges much deeper and much further. And that's where Play Code Learn came from. So Play Code Learn has been developed. When we got together, we all brainstormed lots and lots of different ideas for a educational kit. Now, the kit combines and uses lots of different teaching models. It's based on over 25 years of experience in the classroom, not just from myself, but we usually go into schools. We do lots of prototyping, lots of testing and trialing, and we work with tertiary educators in the STEM and education space too. So we know that we've based this on quite a few different models and quite a few different practices that are currently out there, and we'll explore some of these as well today. The key concepts was we wanted a play-based learning model, which was engaging and motivating for all of our students. We wanted to hook them into learning through something fun and interactive. So you'll find that the activities are very hands-on. We call them unplugged activities when we're teaching different computational thinking and computer science concepts. So they actually start to learn about computer science without actually touching anything digital, no devices, no apps, and no software. We use that approach because there is actually quite a lot of research out there to support this unplugged to digital approach. And so what we do is they learn the concepts, they learn the terminology, they practice some of the skills and techniques like algorithmic thinking, unplugged, and then they transfer that knowledge into a digital environment. And it's been found that by doing this kind of approach, it reinforces concept knowledge and understanding of the key concepts further for the students, and they learn to transfer their knowledge and skills across as well, different boundaries. The other thing that obviously makes us a bit different to everything else is our augmented reality. All of our things come to life in AR, and we're one of the first companies to do that in this space where we're moving from just using AR to actually creating with them for AR. So you'll see some of that as well. And we also have created an online teaching portal. So there's three elements to the kits: a physical kit, an online app, which is our augmented reality and programming side, our ByteEd app. And then we have an online teaching portal, which has lots and lots of teaching resources for people who are not strong in this space or need more support and help to build their confidence with the implementation of this learning in the classroom itself. And of course, we're Kiwis. So we're based in Auckland at VR Boom. That's our main area, our headquarters. And a lot of our resources have Te Reo running through them as well to help and support our identity of being New Zealanders. So I've mentioned some of the background to the Play Code Learn kits, and as you can see, these are some more of the different ideas that were dumped in when we started to brainstorm about what we wanted. Now, I'm not going to go into a lot of this now because we have actually covered this in our Tech Week presentation last year. So if you are interested in learning about some of the literature and some of the research to support the ideas behind the Play Code Learn kits, especially the Dinosaur steps, our first one, then if you link to this bit.ly, so it's https://bit, so bit.ly/ and in capital letters it's BE for ByteEd, and it's TW for TechWeek, and it's 2022. So that bit.ly link, and I will send this out to you as well in an email, should you forget this. But if you want to use that link, it takes you to the ByteEd YouTube channel, where we've got lots of different videos and resources there, so you can see some more of our content that we have, and you can actually view the background to the Play Code Learn kits themselves. So one area which we always think is really important is this SAMR model approach. So this really underlies quite a lot of the teaching resources and how we've created them at ByteEd. So we follow this model because this is something that is used worldwide for the implementation of digital technologies and e-learning approaches in the classroom. And essentially what you usually find when people are starting off, especially at a young age, is many teachers and students work at the substitution level. So what you find is they are using tools and it's a complete swap from an analog version. So one way of thinking about this is if you have a piece of paper and a pen and you're writing a story, that's the analog version. If you substitute it for a digital tool, you're substituting it for a Word doc or a Google doc or a note maker of some description, and basically the hands writing is just being turned to typing, and that's a pure substitution. Some people select to use a digital tool for augmentation, and that's where you're actually selecting to use that tool because it has some benefits to it in comparison to do it by analog. So for some students, it could be spelling and grammar checks. It could be adding in links and images, those kinds of things in a digital tool. But really you're looking at that enhancement stage there when we come into teaching and learning. Now at BITED, what we want to do is we want to try and get students down into the transformation stage, and that's modification and redefinition. And this is where we're looking at not just using digital tools, but getting the students to be creators with those tools and getting them to create things for a purpose. So our products are progressive, and they progressively introduce this kind of approach to the teaching and learning in the classroom itself. We have 3 kits in our Play, Code, Learn series. And so as you can see, they all have different aspects of computational thinking that they link to. They have been developed alongside curriculum, and in particular, obviously, because we're New Zealanders, it is based on the New Zealand technology curriculum. It also integrates and weaves in the e-learning side of things, if you're looking at the future focus principle and weaving in those aspects from the New Zealand curriculum too. But if we focus on the computational thinking progress outcomes, you can see that a lot of this terminology comes directly from those. So Dinosaur Steps is the introductory kit that we have. This has been out the longest, and this is what our Tech Week presentation was on last year. And these are some of the basic concepts that we help to teach with Dinosaur Steps. Now, since that last year, we now have 2 further kits that have gone into production. And once again, you can see that the knowledge that they're learning is progressive, and they can build up, and they reiterate and repeat the knowledge that has gone before, but then they build and introduce new concepts to them. And we've tried to make it very sequential, and we've tried to make it so it suits the different ages and the different abilities of learners too, to build their confidence level, but also to build those confidence levels of the teachers who have never taught this before too. So this is an example of the digital progressions that we created as a team prior to us developing the Play, Code, Learn series. For any of you that have seen the New Zealand technology curriculum, you will see that there is a huge amount of content from the technology curriculum directly linking to our own progressive standards here as well. Now, the reason being for that is because the New Zealand curriculum went for a very, very new refresh in terms of weaving in computational thinking and designing and developing digital outcomes not that long ago. And when they did that revision, they did look at other kinds of curriculum from across the world to help and develop this, but also have its own New Zealand slant on it too. So a lot of the terminology from here, yes, it is directly from the New Zealand curriculum, but it has actually been based on, say, the computer science curriculum in the UK, for one example. So yeah, it is actually weaving international curricula and that progression as well. As you can see, we've tried to identify the progressive learning as well with our kits coming through, both in computational thinking, so learning computer science concepts, but also going into the creation and understanding the impact on society and technological systems kinds of things for the 3DO side too. So that's a brief background into our kits themselves. And what we're going to do is we're going to now explore step by step our actual kits that we have in the Play, Code, Learn series. So like we said, our first kit that we have is called Dinosaur Steps, and it introduces the basics of algorithmic thinking, essentially. So in here, we have a physical kit. As you can see, you get a massive box of kits. Oh God, you can't really see them behind me on my shelf because I've got a big screen up, but oh yeah, see, I'll cover myself if I do that. So we have a great big box with lots and lots of content in here. Like we said, it is using a play-based or game-based approach to our kits that we have. So in this particular one, the students, you can see they have a jigsaw actually, and what they do is they have lots of jigsaw pieces and they put them together. Now, what many teachers and students don't realize until you explain it to them is just by putting a jigsaw together, they're actually learning some of the different computational thinking concepts. For example, you're doing pattern recognition because you're matching colors and shapes and lines and things on there because it makes the dinosaur land in a grid once you put it all together. You're learning the concept of decomposition because you've got lots of small parts, and when you put it together, you make a whole. So that's what decomposition is when you've got a problem, you break it down into small parts and it makes it easier. But once you've done everything, it makes a whole. Same kind of concept. So there are quite a few different computational thinking ideas that just come from that hands-on jigsaw approach. Also in the kit itself, we have our activity cards. So you will see that there are lots of cute little dinosaurs that we have, and we have lots of cards to help with the programming side of things too, and the algorithmic thinking sides. And supporting the information for teachers and students, we have got informational flashcards, which you can see in the middle of the picture there. These are for students who can't read yet and struggle to read, so that it's all in a visual form for those kinds of students. Or we have got an informational booklet. And so in the informational booklet, it goes through how to use the kits and introduces lots of terminology, which we'll show you in a minute. And then every single kit has a series of challenges. So they're preset challenges, which slowly get harder and harder. And they're in the unplugged side, and they're also in the digital side too. So that's really what's inside the physical kit from Dinosaur Steps. When you are creating, this is what happens. So the students, as you can see, they put the jigsaw together. If you follow the images on the right-hand side there, once they have put their images together, the jigsaw pieces together, they create a simple dinosaur land, which is like a grid. And then what they do is they start to plot paths. So we have different command cards. So in the cards themselves, I'm just trying to find some of them, we have start and finish flags, and they position those on the board within the squares. And if they want to increase challenges, they can add dinosaurs. For our main character of the piece, Explorer Ed, who's our little robot here, who actually goes around on safari to meet the dinosaurs in this case. And as you can see, they use these little footprint cards to plot the path. So they're really thinking carefully about the route things are going to take. They can look at efficiency. So can they make the shortest route possible? You can add obstacles like, oh no, miss the volcano, it's erupting, those kinds of things if they want to make it more difficult. Once they've plotted their paths, you can see the students start to use what we call command cards, which are the arrow cards there, and they start to write simple instructions to give directions for Explorer Ed to go from start to finish visiting the dinosaurs, essentially. They test and trial, they spot any errors, they learn debugging. So if they find bugs or errors, they debug. In fact, let's have a look. See, these girls, they were testing and trialing, lots of group work, lots of problem solving, collaboration. So those are year 4 students who are using the kit in their classroom. What you didn't see just before that clip there was actually they had to swap around the students who were reading out the instructions and following them, because one of the girls actually didn't know her left from right. And so she struggled to read out the instructions correctly. So they're working on collaboration, they're working on communication, and they're also developing those motor skills that they need for just everyday activities too. So we do try and link to not just computer science, but also like those key competencies that we want to try and promote, and those 21st century skills too. Once they've got a handle on the unplug side of things, then we go into the digital, and I'm going to pass on to Thomas to explain the digital side.
Well, thank you, Sarah. Yeah, so as I was saying before, with how the Play Code Learn app itself works, it essentially takes what the kit already provides, and we also now bring it into AR. So we have an example here with the GIF on the left-hand side, with a little interactable dinosaur that you can see on there. And this is something we can actually try now if you would like to give it a go yourself. So you can see another big QR code in the center of the screen there. If you do scan that, it will just take you to another page on our website, very similar to the other demo page, except this time, what it needs you to do is to scan an image and then see a dinosaur appear. So the image you need to scan is of the pterodactyl there on the screen there. So the that white square-ish shape right next to the QR code. If you scan that, you'll see a AR model appear. And this is how AR technology generally works. And this is what we get them used to by using the technology, understanding how it works and just experimenting with it. There are ups and downsides to AR technology, but this is those are things that you learn just by using the technology over and over again. And as you scan these models, you'll see them pop up. You'll be able to move them around, rotate them, and then once you've actually got the board put together, they can actually interact with each other on the board as well. So we really want them to get exposed to how this technology works. As we were mentioning before, you can kind of do everything that we just mentioned in the app as well. So you can explore the Dinosaur Islands, you can go into challenge mode and try out all the different challenges. You can now go into technically what we call now programming. You can turn your algorithms into digital programs and have a digital version of your Explorer Ed move around on the board, visiting all the different dinosaurs. And we also even have bonus content on the app here as well. So we've also got access to a glossary where you can go and learn about each of the different dinosaurs in the kit itself, kind of what their attributes are, and then you can also see their 3D models, at least how we have depicted them, as there's not super realistic representations of them, but more meant to be about fun versions to get them interested in learning about it. And this is only just for the first kit. As we mentioned before, we've actually kind of got lots more in the works as we'll be going over shortly, but I think that's everything. I'm not sure if I've missed anything there.
Oh, thanks, Thomas. Yeah, so working alongside, obviously that's the app side of things, and that's the part where they're learning about AR and they're learning about coding and programming. So they're reinforcing the learning with the unplugged kit. This is just a bit of a close-up so you can see that we actually also, with the kits, not just look at computer science and STEM, we also integrate as much as possible with as many different subject areas as possible. Because I know from being in a primary school for quite a few years now and observing classroom teachers are time poor and they have to try and cover everything in a very short amount of time. And what we don't want people to see is this is a kit which is extra and on top of the learning that's taking place at the moment. We want you to think about how you can weave this in, whether it's through key competencies, whether it's through the computer science element or integrating with other curriculum. So this is just an idea of how we've started to think about literacy and the students exploring literacy. So as you can see, you've got your visual instruction cards in the booklet itself that you can see there. We've tried to make it as informative as possible for students. If you have some young learners who may struggle with reading some of these pages, in the top corner we also always have a QR code, and now this is child friendly as well because the audio file goes to a child that's actually reading out the page for them, and it turns into an audio file essentially. So you've got an audio file linked directly to the books themselves. We also have lots of terminology in here. So if they're learning a new word, particularly that links to digital technologies, it's in a different color and it's usually spelled phonetically to help with obviously the speaking of that word too. And at the very end of the booklet, we also have a glossary which reinforces the learning that's taken place. So what we're trying to do is really make sure students can understand the different terminology and digital literacies that they need to go further. Now, this is a step up from last year's Tech Week as well. And I'm just going to thank, because I can see Mel's on here. So last year, what we did, we decided it was really important to have a look at the impact of this learning and this approach on students within classrooms in New Zealand and just see, is it making a difference, this the actual concept, and do the kits make a difference to students in the classroom? So we focus on two main areas really. It was looking at, is there a shift in their knowledge retention when it comes to understanding the terminology, but also being able to do things like write algorithms and spot bugs. And so those kinds of skills and techniques that they're learning in the process too. So last year in term 4, we went and we approached, we've got two awesome teachers, and Mel's on board at the moment. So she was one of the people in her school. And they actually went through this pilot program with us. And you can find out more of those, an impact report there. So if you can see the bit.ly link on here as well, once again, I'll send this in an email to you as well. But you can see the impact based on pre and post testing before and after the use of the kits and the teaching module that you can see in here. And you can also see the difference in knowledge content creation and remembering terminology and understanding some of those underlying concepts through the use of the kits.
Now, this one was, because it was taken in term 4, both of our school teachers only got up to, they only completed 5 lessons at the 10 lesson module, and they didn't actually get onto the converting to digital. So the results that we've got is actually only on a partial part of the learning that was going on, because we all know how bad term 4 is, with visits outside of school and report writing and everything else that hits us as teachers in term 4. And so what we're doing now is actually we're going much deeper with this impact project. So we're calling this our pre-pilot now, even though originally it was our pilot project. And now we've reached out to, we've got many more schools and teachers involved in New Zealand and also in the UAE. And we've got people hooking on, and they're going to go much more in depth with us. So if you're interested, watch our spaces, watch our social media things and that, because you'll be able to see, hopefully by the end of the year, we will have a much more in-depth look at the impact of these kits on learning in the classroom too, if you're interested in that kind of research and that kind of support for your teachers. But once again, thanks to Mel, who's on here now. And yeah, if there's any questions at the end, she may be able to answer some of them potentially, but we'll leave this here for you and you can explore this one in your own time. So this is what we love about ByteEd. Not only does ByteEd try to support the creation of resources, but we're also trying to support, because some of us are in tertiary education, we also want to reinforce the learning, and we have research and development projects that Tom's can talk more about at the end of the session if you're interested in that, looking at using PhD students in VR content creation, for example. So we do a lot to support the tertiary education side and the research into this space as well, both from an educational point of view and from a VR content creation point of view too. So that's STEPS, and STEPS was our basic introduction into setting the scene essentially for computational thinking. Dinosaur Loops is our next kit in the progression. And so once again, it is set up very similarly to Dinosaur Steps, because it's for slightly older students who have got the concept knowledge. There are some differences, though, that we're coming through. So this time, instead of having jigsaw pieces that they put together, we have these tiles that you can see on the screen there that the students are connecting together. Now, well, this is quite cool because they all tessellate, so you can actually bring in lots of mathematic principles with some of these things. And so, yeah, so we've got tessellating tiles where the students can actually start to design and create their own dinosaur lands. And all the flora and fauna on each one of these tiles are directly linked to the flora and fauna of the dinosaur age period, the Mesozoic age. So, for example, the heart-shaped leaf ones that I've got here, they're the ginkgo tree. And so those have actually continued on to today. You might recognize some of them. Same with cypress trees and palm trees and ferns and things like that. So if you want to go down an angle and go down that offshoot of looking at science and biology, you're more than welcome to. Same with paleontology as well. Once they've gone and they've worked together to collaborate, and you've maybe done some research into habitats and landscapes of the dinosaur period, they can design and create, like we said, their dinosaur lands. These can be any shape, size, orientation, whatever they want to do. And believe me, this activity always takes longer than you expect, because they are always very specific about what needs to go where and which way round it has to go. So be prepared to spend a bit of time on this one, but it's very hands-on and very engaging. The concept of writing algorithms is very similar as well. However, this time, instead of just focusing on moving forwards, backwards, left or right, we introduce some other concepts. So the whole focus of Dinosaur Loops is what we call iteration. And it's where we start to get commands and we start to make programs or algorithms more efficient. We're trying to reduce the size of them. And so we start to use repeats. So we have repeat commands in here. And then we also start to introduce loops, so repeating series of commands in the kit too, and that's iteration. So that's that next step up for students in learning. As part of that, the key focus, computational thinking focus in here alongside algorithmic thinking, is then pattern recognition. And there is a huge amount of linkage there with maths. And you've done lots of things with this probably, with sorting and recognizing patterns in a series, what comes next, those kinds of things. That is pattern recognition. So you can actually use that in lots of other subjects too, and integrate it and weave it into these concepts. It also introduces turning in space. So you're actually getting them to look at direction, transforming around a grid, and also turning 90 degrees, left, right, etc., etc. And so we've got loads of teaching resources to help and support with that area as well. I'll let Thomas explain the next step up when it comes to the AR app, because that's quite cool. I quite like Dinosaur Loops. But once again, here are some students.
Yeah, about here. No, we go. I think we just take it for no, but we keep them on there so we can go our part. Then we put the finish too far away. Yeah, we should put it here. Yes, we did it.
And I always love watching that video because they had to slightly cheat to actually get to the end, and they were really excited about actually doing it at the same time. So, but it's fine, it's problem solving, they're figuring things out through a problem, and they're also working together, and they're understanding the progress and the sequence they have to go through to create the algorithms as well. So lots of teamwork, which is fantastic. Thomas, away for you go and explore the app for us this time.
Sure. So very similar to Dinosaur Steps, in the new version for Dinosaur Loops, we also have all the same sort of stuff again digitized. One of the main aspects of Dinosaur Loops was the tiles that you could put together yourself and create your own custom landscape, essentially. Well, you can actually do the same thing in the app as well. You can go ahead and create your own custom landscape in the app, getting them to use UI interfaces and get used to using these digital tools. You can kind of see the images on the right-hand side of the screen are them putting together their digital tile map, essentially. And then once they've gone ahead and created that, they can click on the AR button, and it essentially allows them to project that custom-made AR world onto a flat surface. You can scan one of our tiles in the kit, and your very own created digital world essentially pops up in front of you. And then you can actually go ahead and start placing all the other dinosaur cards on it and interacting with it in the exact same way you would with the physical kit. So really just adding that little bit of extra creativity as well as the play-based aspects to get them engaged with the content. But then they still get to go and explore and use all the different tools that they're going to be using to solve all the problems. So we were mentioning before, we now got loops, we've now got iteration. We can obviously now all do that in the app as well. So some of the GIFs down the bottom there that are playing, they can go ahead and create their own program and algorithm. They do this by dragging essentially code blocks or code nodes around on the board, and they can rearrange their code, they can make it iterate, they can remove it, they can add loops, essentially emulating what they can do with the physical kit pieces as well. But now their programming is kind of taken to that next level and is slightly more advanced. A lot of the challenges that we've got integrated into the app on this, we've got about 60 challenges per kit, by the way. So the 60 challenges in this kit really start to focus on that idea of iteration. So many of the challenges will actually get you purposely to try and use loops to create those looping patterns. So moving in a square, for instance, moving between all the 4 points of a square, many of the challenges will actually get you to think, how does that work? And how can we create an algorithm that just repeats itself 4 times to go to each point of the square? So thinking about efficiency there when you're programming as well. As an added bonus feature to this kit, like we had the glossary in the previous kit, we've also got the glossary here again, so you can jump in and learn about the new dinosaurs in this kit as well. We also have a gallery, and this allows you to essentially take pictures of all the dinosaurs wherever you want using your device's camera. So using the same AR technology that just you can place the tiles anywhere you want and have the AR model appear on it, you can actually scale this model up to be as big or as small as you want, and you can actually go and take pictures of it wherever you want. So you can, as an example, go and ask them to take a picture of a dinosaur in a habitat you might find it in. So you can get them going outside, putting them into bushes and then taking pictures of the dinosaurs really large or really small. You can get them thinking about, how big and small should they be relative to the environment as well, and do a little bit of research into there too. So we've tried to really integrate, as we said before, everything you can do physically into the digital app. And this is mainly due to accessibility. We wanted to make sure that no matter kind of what way you're interacting with our product, you're still going to get the same outcomes by the end of it.
Oh, fantastic. Thanks, Thomas. Yeah, and so the added features with the AR and the obviously the creation side, we're moving through that SAMR model that we talked about earlier, but also we're letting you as teachers decide the different curriculum subjects you may potentially want to link to too. And not only do the photographs save in the gallery, they can also save to the device. So if you want to be able to take that snapshot and they can write a story about it, or they can do some scientific research into that, or whatever you want to do, they can use that as a resource to help and support further learning as well. So as you can see, Dinosaur's Loops is a little bit of a step up. There are more cards. The challenge in this case, instead of just visiting the dinosaurs, is we've got an erupting volcano, and the Explorer Ed has to basically go around and save all the dinosaur eggs, all the dinosaurs, depending on what you want to do. Another interesting point is if you can see the AR board down at the bottom, so you can see the overlay of the dinosaur, the AR dinosaur land on top of the tiles, so you can see they interact and work together. The volcanoes also erupt. So Thomas got asked by some of our students saying, we want an erupting volcano, and he had to come to the party and actually create it. So I think it's a bit of a challenge, but we've got it, and so it is quite cool. So there's further things that they can actually play with and use, and obviously then you go into geological features and how they work if you want to go on a side tangent with that kind of learning too. In this kit, they don't have the visual instruction cards because this is for slightly older students, but the main instruction cards still have the audio QR codes on there, so you can still use those. And the challenge cards, they like Thomas was saying in the app, these challenges, they obviously reinforce and reiterate repeats and loops based on geometric shape a lot of the time. So we're even in other aspects of maths as well coming in here. And for there are extension tasks, so 9 and 10 actually go into nested loops. So the kids have got to think a little bit further as well. So we're trying to push them on a bit for more. And then our third and final kit is coming through to Dinosaur Commands. And this might be what Mel's on here for, because Mel hasn't seen the commands kit yet. So Dinosaur Commands is for our slightly older students again. So once again, it reinforces and reiterates all of the learning that has gone before in the previous two kits. Okay. However, because this is for slightly older students, what we are suggesting is the kits themselves, it's not necessarily a play-based approach, it is more of a game-based approach. All right. So in my own classroom, I use a lot of game-based learning approaches and gamification approaches to help to teach different concepts to my students. And so this actually uses both of those concepts. We have game-based learning, and we also have gamification through the app as well that we have. So let's explore the Dinosaur Commands. So Dinosaur Commands kit itself is actually based on all the age periods of the Mesozoic age. Okay, so depending on the ability level of your students, there are actually 3 maps. The one you can see is the main map. This is based on the Cretaceous period. On the other side of the board, there is also the Jurassic period and the Triassic period. But those grids are smaller and the squares are slightly bigger. So what we do is we can actually differentiate the challenges that we set for our students based on the design of the grid and the land. It's also based on, obviously, how the land masses have changed. So we're weaving in those geological things, we're weaving in history, and so we're exploring how the lands of the world have changed over time. And all the squares you can see there, they've got different images. Some are green, some are brown, some have got imagery in there. They all directly link to different landscapes and features of that time period, and they are in the approximate position of where they were found during that time as well. So the mountains are there. You'll notice that there's no ice in the polar caps, right? They were actually forests at that time. And then obviously we've got the Ring of Fire, which we all know about, is actually indicated on here too. And so we've tried to weave in as much as we can to like other curriculum subjects, like we said. Now, once again, with this kit, you can actually introduce all of the concepts from loops. So you're bringing in directions and repeats and loops and all those kinds of things. But through the gameplay, because now we've actually got an Escape the Predator game, we have our baddie, which is the Irritator dinosaur, which I didn't actually realize was a dinosaur until somebody bought my youngest son a t-shirt saying Irritator, which I thought was highly amusing because it suited him right down to the ground. But we decided to make the Irritator dinosaur our our fiend of the game. And so the irritated dinosaur is one of the few dinosaurs that can go in water and on land. And so there was a point to it. And so what we've done is all the other dinosaurs have got to try and get to a safe space. And we also introduced that there are also marine reptiles and air reptiles, which actually weren't classed as dinosaurs. So we do go into different types of classification in here too. Essentially, they have to follow some rules and routines and use algorithms to actually escape the irritator. So they're using the knowledge that's gone before, and they're using it for a purpose this time. They're using it to try and escape. Also introduced to this is looking at variables, because we've introduced dice into the game. So we're bringing in random variable concepts in there. We're introducing things like conditional statements, because we have what we call an events round. And so we put that into the game as well. And there's some other aspects as well that we're introducing to when it comes to computer science, things like broadcasting and functions, and lots of new terminology, which will help and support them when they go on further too. Now, what was interesting was the two boys that you can see in there. They're Year 7-8 students, and one of them was a dinosaur expert, which I didn't realize at the time. So he gave me lots of feedback about dinosaurs and which ones we should include in the kit. And the other child there that you can see was he saying that he did a lot of Python programming at home. And I thought, oh my goodness, is he actually going to like the kit? And he loved it. I didn't have enough time with them to finish playing the game when we were in the class, because they had to move on to another subject, but they wanted to carry on playing. And they learned then the terminology, because at the beginning, when I was asking him, oh, well, can you tell me what a variable is? He couldn't tell me. But at the end, he had that conceptual knowledge of what it is, because he'd used it. And so it was much more effectful and powerful by using this as a resource to help teach them, rather than him just learning to type in lines of code and just copy things essentially to get things moving on a screen, or doing something on a screen in a piece of software. So they understood it a bit more. We've also gone a little bit deeper with our characters. And so you can see that we have these dinosaur fact cards. They're a bit like top trump cards. So you can do that with your students, and you can create your own with the students as well, should you wish to. But yeah, so we're looking at all the different dinosaurs and some of their different features. So lots of maths, lots of literacy, and lots of statistics coming in there too. Thomas, do you want to mention anything about the AR and the app side before I move on to the next slide?
Yeah, sure. So we do have, again, bringing that same concept of kind of bringing everything that we currently got to life in terms of the app as well. Everything that we've got built in, or everything that we've got in something you can do physically, you can also do digitally with the app too. So again, we have 60 challenges that you can go through on the app side, but as the challenges progress, the map itself also changes. So as you go through the easier levels and get harder and harder, you actually start to expand on the bigger and bigger maps to make it more challenging there as well. We've got, as you see here, plenty of other stuff with the app here too. One being our customization section. So now you can also go ahead and customize your own dinosaur. We kind of thought about this, again, adding in that play-based aspect into it, but what's something unique that we can do now that they're getting to a slightly more advanced level. And again, it also kind of secretly reinforces the ideas around variables, because essentially, as you customize your dinosaur, you are just setting all the different variables for that dinosaur. What is its color? What is its pattern? How strong is the pattern? How many times should that pattern iterate? All these different things are variables that technically get saved behind, you know, the black box, so you don't know how it works. And then once you load back into the app, all the app does is just takes those variables and then reassigns them, and then you've got your custom dinosaur saved. So that's one aspect of it. Again, you can view your custom dinosaur in AR space, so you can project it into a living room if you want, scale it up and take a picture that way too. And we've also allowed you to roll dice using the AR system as well. So whether you want to do a lesson in statistics or learn about how dice rolls work, essentially, we've got an AR version for that. I don't think there's actually a limit to how many dice you can roll, so you can kind of freeze your phone and just roll about 30 dice at once if you really wanted to. But it's a quite fun way to, again, explore how those statistics work and how probability works with dice rolling. I think that's pretty much all the unique aspects compared to the physical kit. Otherwise, again, you can also play the Escape the Predator style game that we've created in a digital format as well. Again, these uses and introduces the idea of events, and events are quite a popular thing that happen in programming. So it's a really awesome way that we can introduce here at this stage, as essentially when you do get to that stage where you start doing text-based programming and digital programming and editing all that stuff yourself, you'll probably find events are things you'll end up using quite a lot. And in fact, pretty much everything that we've been going over is stuff that you end up doing in programming almost every single day. I don't think I've gone a day programming without debugging my code at least once. It's a skill that you learn and you use over and over again, and you do actually improve at it. It's not just something that like you pick up straight away. You do actually get better at debugging the more and more you go through. So again, it's that exposure, giving them experience and building their skills up from the ground, essentially.
Fantastic. Thanks, Thomas. So essentially, those are our 3 kits that we've got together. And like we said, what you've just seen is you've seen the 2 supporting pillars. You've seen the Unplug side and you've seen the digital ByteEd app that we have as well. Now, we said there was a 3rd pillar to this, and this really is what makes us a little bit different to other teaching resources in the digital technology space, because we have created an online platform which has lots and lots of different kinds of teaching resources to help and support you with the learning in the classroom. So this is just a whistle stop. There are many, many more, and we also start to introduce and hook into other types of digital technologies here too. So the main types of resources we have to support the learning with the kits are the following ones that you can see here on the screen. So we have an interactive website, so you can actually go and explore if your students are struggling with a particular concept, for example, like debugging, you can go into our How to Teach Computational Thinking webpage, and there are a huge amount of activities on there where you can find debugging, and you can click on a list and it will take you to an activity that you can test and explore in your classroom with your students. And there are lots, and they're all directly linking to algorithmic thinking concepts and all the other computational thinking concepts too. So things like decomposition, abstraction, pattern recognition, and logical thinking, they're the main areas that we're focusing on. If you wanted to see how you can actually integrate the learning from the kits and the concepts and ideas that we have another page which gives you ideas and suggestions of how to integrate it into other subject areas too. Now, these are just a starting point, and teachers are awesome at making these connections, and so are your students, but you can go down whichever pathway you want to, but they're just ideas and suggestions for you too. So in the Dinosaur commands area image that you can see at the top there, we're looking at life cycles, and so we're looking at those because they're actually systems and they're following a process, which directly links to what we do in computer science too. If you wish to extend the learning from the students, we have these challenge activity cards. There are 8 challenges per computational thinking concept. These reinforce and reiterate the learning that is going on with the kits. They can be used as extension tasks or 5-minute fill-ins if you want to, and they all come with the answers and a paragraph explaining how they link to computational thinking. So we've done all the work for you. And the other thing to help you, which we've done all the work for you, is every single kit comes with a comprehensive 10-lesson unit of work. There are 5 optional extracurricular integration lessons, but every single lesson has clear learning intentions. It has the links to computational thinking concepts and digital technologies concepts and understanding, links to other curriculum areas, and it's a completely scaffolded and differentiated lesson to suit you and your students. So you as a teacher, you just go in there, you pick and choose what you want to do, what's appropriate for your learners, and you take it and use it. And every single lesson has supportive teaching slides and printables for you to download and use too. And if you're in a school where you have to assess against the technology curriculum and you have to provide evidence of the work, we have formative assessment documents there. So there is one directly linking to the New Zealand curriculum, and it has direct links to the computational thinking progress outcome as well. And so you can actually highlight the criteria for your students to achieve and meet success in. And then there are student reflection forms and sheets as well, so they can check their own progress too. So that's some support for teachers in the main general area. And then we've got a wide range of different types of resources to suit the different kits, depending on the age and the level of the learners that are taking place as well. So with Dinosaur Steps, for example, we've created our ECE or Absolute Beginners resources. This slideshow is huge. There's loads and loads of activities and ideas in here, but really this is actually what they need to know before they start even programming coding. Things like the commands, stop, start, finish, run, play, forward, backwards, left, right, those kinds of things. And so we actually try to introduce those concepts through lots and lots of different activities, and integrating and weaving in literacy and numeracy and hands-on practical play-based kind of approach as well. So there's lots of ideas in there for you. Like we said before, we've got challenges, both digital and unplugged. And we also have other aspects as well. So every single kit now, we have provided the STL 3D printing files. So you can have a look at those. Oh, thanks, Mel. Mel's just put in the chat, ECE is great for differential learning for lower level students. Awesome, thank you. She's been practicing using some of these resources, so it's great to see a first-hand point of view from teachers. And so you can, if you've got a 3D printer or access to it, you can actually 3D print all our models, and you can, if 3D print Explorer Ed, there are lessons created for 3D printing as well. So you can, if you don't know anything about it, you can still teach it, because we've got all the resources there to help and support you too. We're in the process of creating more, but in Dinosaur Steps, we've got tutorial videos if you want to learn a bit more in that space. So the ones we've got at the moment is for ECE and Absolute Beginners, and we've also got a tutorial on storytelling and how you can use storytelling in the classroom to teach computational thinking. So we're going much deeper and doing a lot more links to other curriculum subjects too. Alongside that goes the ebooks. So Steps and Loops have got these introductory ebooks that we have, where Explorer Ed goes on an adventure, and it helps to introduce how to read algorithms. You can download them as big readers if you wish to, or you can project them up as an ebook. It's entirely up to you, but they go through a story, and they actually find different activities for Ed to do as it goes through the story. When you get to loops and commands, the next step up, we actually have tutorials in that creation stage of the SAMR model. So students can learn how to create 3D models using software, and they can create their own 3D dinosaurs. So they start with just simple geometric shapes and creating dinosaurs that way in loops. And then in commands, we have actually got 3 sequential 3D modeling lessons, where they go from creating simple 3D models of 3D shapes, going into programming their own 3D models using the different things that they have learned through the Dinosaur Commands kit. And the extension one for Dinosaur Commands, the extra for that is the teaching with dice. You guys probably know as teachers, there's lots of things you can do with dice in the classroom, and these all integrate and weave with lots of different curriculum subject areas too. And the final one on there is the Dino Fact Cards. The Dino Fact Cards were so popular for the Commands kit, we got screamed at to make more for the other kits. So we've actually created them for all the kits now, and you can download and print them in your classroom too. So that's a very fast whistle stop through some of the different resources that we have. These are some of those ECE and Absolute Beginner resources that we have for looking at pattern recognition. You'll probably recognize a few of these activities, but directly linking to the Dinosaur Steps kit, and numeracy, measurement, all those kinds of things, direction, moving around a grid, all those kinds of things too. So in the app itself, I'm very aware of time. We've only got 2 minutes, so I'm just going to whistle through these bits. The app itself, there is a teacher page on there as well, where you can upload your own students. They can have their own individual profiles. You can check their progress through the digital challenges, so you can see how well they are doing, and you can actually see where they need support. So these are in there as well. So it's a big classroom management system in the app too, for supporting teachers with assessment and checking the progress of learners.
Yeah, it also allows them to sign into the app a lot easier. With how we get you guys into accessing app and accessing all the different areas, you generally need to sign in with a username and password. But with that new system in place, essentially you saw like a small teacher code, similar to how a lot of other applications and websites do it. If the student just inputs that little code in, it essentially automatically assigns them to the teacher's account, and then they can just log in that way, making it easier to not only get them onto the app, but then, as Sarah was saying, check their progression, check how they're doing and all that stuff as well.
Oh, thanks, Thomas. And as you can see, we do have testimonials from teachers in the classroom from a wide different range of backgrounds, whether they are new entrant teachers, whether they are digital technology specialists as well. And we've got some more for loops here. You can see we're going up to year 5 and 6, and even school principals are getting stuck in and having a go at some of the kits. Yeah, and sometimes actually it's harder to get the kits away from the teachers who are using them than the students themselves, which is highly amusing and quite interesting. So how do you get hold of a kit? Well, if you head to our website, so like I said, you've got byted.com, you can find out more about the Play Code Learn series. You can find out more about ByTed. You can also explore some of our VR stuff as well. And there is a way that you can contact us if you are interested in this space and finding out a little bit more about the kits and how we use them. When it comes to how many students per kit, normally we suggest about 2 to 3 students per kit, depending on the age level. So I've been, like, for example, with Dinosaur Steps, I've been in a new entrant class, and it's better to work 2 students to a kit rather than 3 because of the age of the students, and we don't want them fighting and arguing over the different pieces. It does happen. Whereas when they get to commands, actually to play the game for Dinosaur commands, if they're playing the game, they can have up to 9 players in that one game. However, I wouldn't suggest 9 players when they're learning the concepts for the game. I would probably go to a maximum of 3 or 4 potentially. And that's the end of our session. And what we'll do is before we sign off and give you some links that you can look at in the future as well, if you have any questions, please just pop them into the chat and then we can answer anything for you. So whilst you're doing that, we can answer any questions that you have. So just type away in the chat for us. And whilst you're doing that, you can see that here, we can answer questions in a second. If you want to keep in touch with us, there are lots and lots of ways to keep in contact with what we do at ByTed and what's coming up next, because we've got really exciting stuff in the pipeline. I can't wait for Tech Week next year when that comes along, especially with some of the things that Thomas is working in. So you can, we have our website, but we're in all different types of social media, Facebook, Twitter, LinkedIn. We do have some of our unplugged resources available for you through Teachers Pay Teachers or TES, should you want to have a look at some of those. Be aware they were created a few years ago now, because obviously our main focus is on Play Code Learn kits, but you can see some of the ideas that we have there to help and support computational thinking and computer science. This video that's been recorded will be popped up onto the YouTube channel too, so if you want to refer back to it in the future, you are more than welcome to. Thanks, Mel. So Mel's just saying, thank you for all your hard work, team. My students love the dino time. I like how you've got a special time for it in the classroom, which is fantastic. So I don't think we've got any further questions. So I'll conclude and finish our session today. On behalf of Thomas and myself, thank you for taking the time out of extremely busy, hectic schedules that we have. And for at least now, I think the weather's not too bad. We've not got torrential rain coming down or anything at the moment. I'm not sure what it's like in Auckland. I'm in Queenstown, but it's actually sunny. We've still got snow though, so it's still cold. But thank you for taking the time at the end of a busy school day to come and join us. And we'll finish with our karakia for the session today. Ka whakarea te tapu, kia watia ai te ara, kia turuku, whakatahi ai, humie, huie, taikie. And kia ora everybody, thank you very much for joining us today. We hope to hear from you in the future. Kia kite.